Hello,
Good evening, sir.
good evening. Good evening. So, to, I just told, right?
Sir, I joined late.
Okay. So today we are going to discuss mainly the threads, right? So from the threads again, I told I'll be mainly focusing on the programming part because if you see the previous terms questions, so mostly the discussions were on the questions were on the programming only. So the theory part is mainly for the conceptualization, understanding the thread properly, right? So uh, please uh, try to understand it properly. Okay, so let me um, start the discussion. So initially, uh, in the first lecture, so there is some idea about what is multiprocessing, and it is shown that we can achieve it in two ways. One is using multiprocessing, another using multi-threading. So whenever we go for a multiprocessing, means multiple processes are running simultaneously, we say processes are running in parallel, right? But whenever we have multiple threads which are running simultaneously, we say it's a concurrency. And how we achieve it? We basically achieve in a interleaved way, right? There is some fine difference between process and threads. So process, as we have discussed before also, whenever we run a program, basically there will be different segments will be created. There will be a stack, right, where the activation records will be stored. There will be a heap. So everything will be created separately, right? But whenever it's a thread, only the local things will be created separately, whereas rest of the portion will be kept on a shared memory, right? So that's why whenever we are having a multi-processing, processes occupy a lot of memory, and context switching means whenever a processor running a particular process, now there will be a switching, right? So whenever the switching happen, so one process is there, right? Then I want to swap it with another process because there is a quantum is over. So I have to take it out. I need to put another process in. So since the size is big, I need to do a spend a lot of time to copy paste the thing. Whereas in thread, since the size of the context or size of the thread is very small, so context switching always happens in a much easier way. Now, whenever we say the term concurrent programming, we usually means it's a multi-threading because parallelism or parallel is normally used for running processes parallelly, whereas concurrency basically means for multi-threading, right? So one more thing, whenever you have multiple threads, you have to understand the variables which are global to all the functions run by the thread will be used as a shared variable. Now, as far as creation of the programs in threads, so you can do it in a two way. One way is extending the thread class, and the second was to implement the runnable. The second was to implement the runnable. But in both the cases, whatever I want to run, I have to keep it into a public void run method because inside the run, so run method is an abstract method inside your runnable as well as in your uh, thread class. So whatever you want to run, that has to be kept into the run method. And if you call the thread dot start, then automatically this run method will be implicitly invoked, right? So a thread could be start with only start method. You cannot call it explicitly. So just to show you the difference between runnable and this thing. So in runnable, so whenever you're having a extend thread kind of a thing, so if you create object of the class, here the parallel extend thread. So if you create an object of parallel, that means you are creating directly object of a thread. So you can directly start this thread object. It's done. But whenever you create a runnable object, So here parallel is a runnable object, right? So in that case, whenever you are creating a thread, you pass the runnable object which has to be run by the thread, right? So in case of runnable object, you have to create the thread separately, then you have to call a start on it. So in the first slide, the important part is how we can create the threads. So there are two ways. So extending the thread class, and secondly implementing the runnable. And how you can start a thread, you have to call explicitly the start method, it implicitly call the run method inside. But if you call directly run method, no thread will be forked. It is something like the main thread only continuing and it is running the run method. So you have to explicitly call the start method only to start the thread. Okay. So in next chapter again, like say next slide again, there are discussion like rest condition. So I'll go for it. Uh, there is lot of discussion with consistency and all. So let me just brief this in a separate way. So there is a program. We have already written this program. So if you have attended or it is already shared on the discourse, you can see how this program and what is the difficulty of the program. We have also shown this whenever we are having a counter, we are incrementing the counter, how it could be inconsistent, right? So the same counter incremented by two threads simultaneously, how the problem still can come. So that is also we have discussed. So this is an example which shows I'm having 100 of accounts. So each account having an initial 1000 rupees say. Now what we do, we randomly transfer the amount, some 100 rupees amount from one account to another account. And also we run a audit function concurrently. Now my idea is if I'm having 100 accounts and each account having the same balance initially, and if I'm to transfer from one account, I take out 100 rupees and deposit into another account. So total balance in all the accounts should be same only, right? But if I run audit, we have seen that whenever we are running the audit, the total amount is little bit differed, right? Every time, because what may happen, because I may have take out the money, but I yet not deposited by that time audit has already run. So there could be many this kind of issues. So that creates a risk condition. So this is we have explored what is the problem if we do not control the concurrency, right? So what is the race condition? Try to understand in a theoretical way. So I'm having multiple thread, right? I'm having multiple thread. So I'm having an account, right? Suppose I'm having a bank account, which is a joint account, right? Now, what is happening? I want to deposit an amount. Another, my partner of the account wants to withdraw the money, right? And this is happening suppose simultaneously. I am trying to deposit and he is also trying to withdraw the money at the same time. So what is happening, we are going to concurrently access a control, and this concurrent access can create lot of inconsistency, right? So suppose I want to deposit 10 rupees, you want to deposit 20 rupees. What may happens? I read the initial balance 1000. You also read the initial balance 1000. Then I put 10 rupees. So it becomes 1000 plus 10. Now you also deposit 20 rupees. You read it as a 1000. So you make it as a 1020. So who have saved later, right? That particular amount will be ultimately reflected on my account. So those kind of conditions called as a risk condition. How to identify a risk condition? So whenever multiple threads are trying to access a shared resource concurrently, then I have this problem. So which is a data consistency problem. So data consistency, if I say in different run, I may get different value for it, right? That's a data inconsistency. Now, how do I solve it, right? The solution, we say we need to run those portions, right? Those portion in my program. So those portion in my program, in the sense here the transfer function and audit functions, which are basically accessing my account, which is a common resource. So both are accessing it simultaneously. That's why I'm facing the problem. Now, how can I prevent that? Right. So if I can identify the portion of my code which is having this concurrent access to the shared resource, we'll be calling it as a critical section of your program. We'll be calling it as a critical section of the program, and we say the critical section of the program must be executed in a mutual exclusive manner. We say this should be accessed in a mutual exclusive manner. Means if somebody already accessing transfer, no other thread can access transfer at the same time. Similarly, somebody access audit, nobody else can access the audit at the same time. So both will be accessed in a synchronized manner, right? So we can say it's a serial access also, right? So one thread access, leave, then only another thread will be able to access it. So that's called a mutual exclusive way. So we say the critical region or critical section of your code need to be detected which cause you the race condition. So terms has to be very clear. What is race condition? What is critical section? What is mutual exclusion? So race condition, different threads are racing to capture your resource because they want to access your resource first, right? Now depends on in which order your threads will access your resource, your result may be differing, right? Now, why the race condition happened? Because there are some piece of code you have in your program which access the shared resource. The shared resource are accessed in a concurrent manner. So that's why I'm having the race condition. So the portion of the code or the region of the code which is having the access to the shared resources called as a critical section. Now, if you run the critical section concurrent way, so you're supposed to have race condition which may give you an inconsistent result. So how do you prevent it? We say the critical section has to be executed in a mutual exclusive manner, right? So which we say afterwards, like in Java, that it has to be run in a synchronized way.
Sir, could you please explain race condition again?
Which one?
Race condition, sir.
Race condition occurs whenever multiple threads are trying to access a shared resource concurrently, right? So as I told, there is an account, right? So I'm trying to deposit 10 rupees, another person also in the same account trying to deposit 20 rupees. So that if the steps happens in a concurrent manner, because since I'm both of us are accessing a shared resource like a account, it could result in a data inconsistency, right? So both fetch the data first. What is the balance? So both suppose get 1,000. Then I add up 10 rupees. Then I save it. It becomes 110. 1,000, he add up 20 rupees, he saved it, it becomes 120. So ultimately I have 120. Although if I deposit 10 and my friend deposit 20, it should be 130. But if I change the order, suppose my friend and me again read the values as 1,000. Now he add up 20 first and save it 100,020. Now then I add up 10 with my 1,000 again save. Ultimately I'll have the value 1,010. So that's basically race condition whenever a number of threads are competing to use a shared resource, right? So now, yes, you're telling something.
No, sir. Sir, and could you please explain mutual exclusion?
Yeah. So now the portion of the code where your code access the shared resources are called as a critical section. The portion of your program or the code, lines of code, which basically access the shared resources called as a critical section, right? Now, if the critical sections are run concurrently, you have this race condition. How to prevent it? We say the critical section has to run in a mutual exclusive way. That means when one thread is executing it, so one thread will enter into the critical section, completely execute the critical section, then only other thread will be allowed to enter into the critical section. So that means the critical section will be accessed in a serial manner. So one thread goes, so I read the account, I add the money, I save it. Then only other person will be read the money, add the money, save it. So if I go in this way, this calls a mutual exclusion or mutual exclusive access. So only one thread can at a time access your critical section. So it enters, completely execute it and come out. Then only other thread will be allowed.
Okay, sir.
Okay. So I go for the next part. How do I execute or create mutual exclusion? So professor has shown historically how it is created, though we are not going to do or haven't done also in Java program all those things, because uh, those are basically if you read operating system or basically do kind of a research on how we can prevent mutual exclusion step by step way. So these are required for your conceptualization. So it's very much required for clear understanding how we can prevent mutual exclusion. But I'll go through quickly because it's not directly connected to our programs, because Java gives you a much sophisticated manner to do all those things. So anyhow, I'll just keep show you the key points, right? So first, using a variable called as a turn. If turn is 1, thread 1 executes the critical section. If turn is 2, then thread 2 will execute the critical section. So that is the idea, right? So now, if turn is set to initially 1, so loop won't be executed. I thread 1 directly enter into the critical section and start executing it. And since the turn is 1, it will be on the while loop. So the thread 2 will be ever waiting until and unless this turn becomes a 2. So once the thread 1 completed the critical section, it want to leave the critical section, it will set the turn to 2. See, turn become 2. Now this wait will be ended. And now thread 2 will be entered into the critical section. Thread 1 will be waiting because now turn become 2. Right. Similarly, whenever thread 1 has done, then it will again hand over the thing to thread 1. But it's having a problem that suppose thread 1 enter, right? But it never set the turn to 2. What will happen? The thread 2 will be ever waiting because it is on a, it will become an infinite loop, right? So that's called a starvation. A thread is waiting for a very long time. That means to get access to the critical section, that's called a starvation. Somewhere it is there, yes. Says shared variable turn, no assumption about the initial value. Atomic update means turn cannot be turn should be updated in a atomic way, in the sense uh, as we have seen, no, that counter value, how it is incremented, it will first saved into the register, then register value incremented, again saved into this. So these step will be done in an atomic manner. So turn 2 won't be happening step by step. So turn 2, like turn will be set in an atomic manner as a single step. So if it is, I'm assuming that, then it will guarantee mutual exclusion, but it can result in a starvation. Suppose my thread 1 is executing, but it do not execute this step. So what will happen? Thread 2 will be ever waiting into the while loop. It will become locked, right?
Sir, it is atomic, like the first point. Like shared variable
That
turn.
is what in setting the turn is an atomic operation.
Okay, single step.
Is a single step operation, yes.
That is
Means it is not interleaved. That's all.
so okay, single step. So that is why it is atomic.
Mhm. Okay, next is, so we do it in a different way. So we check out somebody said the request is true, then only I'll be going into my waiting. So I reverse the thing. So suppose I'm thread 1. If I say my request 1 is true, that means as a thread 1 I'm sending a request I want to execute. So in that case, what will happen? Thread 2 will stop and it will hand over the execution to me. Whenever thread 2 want to execute, it will make request 2 is a true. So then as a thread 1, I'll stop, I'll give the control to him, right? So now see, if request 1 is true, right, request 2 is false. So I can assume if request 1 is true, request 2 is false. So request 2 is false means this while loop won't be executed. I'll directly go into the critical section, I'll execute it. And whenever I'll go out, I'll set request 1 is false because I have completed my execution. My request is over. By the time thread 2 want to execute, he will make request 2 equal to true. So if request 2 is true, that means now thread 1 is waiting. Thread 2 come out of the while, it execute the critical section. Again, whenever it's done, it makes false. So that's one. If request 1 is true, thread 2 will put it into wait state and thread 1 will execute the critical section. If request 2 is true, then thread 1 will go into await. Thread 2 will execute the critical section. But this also has a problem. Suppose both makes the request as a true. So thread 1 say request 1 true, thread 2 also say request 1 true, and they do it concurrently. What will happen? The problem will happen, both the while loop will get activated. So both threads will start waiting, because since request 2 is true, thread 1 will wait for thread 2, whereas also request 1 is true, then thread 2 is waiting for thread 1. So both thread will be locked. So whenever both threads are locked, this situation is called as a deadlock situation. Right. So deadlock situation happens that I'm waiting for a resource which is locked by somebody else, whereas he needs certain resource which is locked by me. See, exactly same thing is happening. I'm requesting to access this. See what happened. I'm requesting to access the critical section, right? So I have set my request 1 as a true. Thread 2 also wants to access the critical section, so request 2 also set to true. So as a result, since request 2 is true, thread 1 will enter into the while loop. It will become a infinite kind of a loop. Whereas this is, since this is also true, thread 2 also go into the while loop. Since both of them are in the while loop, nobody basically comes out and make it false. So this will ever execute until and unless you forcefully terminate the threads. So this calls a deadlock. So using turn, it can result in a starvation because both threads are not locked. One will be starved from another. But in this case, both will be stopped. But you can have a better approach whenever you mix them together. So that's called the Peterson algorithm. So use the request also, turn also. Please read it. If you have a problem, I'll solve it, because it's just a combining both the concept together. So that basically solve those problems.
Sir,
Huh. Yes.
so in this, professor says that there is no assumption about the initial value
Yes.
of like request turn these variables.
Hmm. Yes.
Yes, sir. So suppose if we do T1 thread 1 dot start and thread 2 dot start,
Hmm.
and like suppose thread 1 starts, like anything could start. So suppose thread 1 starts, then it will make request 1 as true, then turn equal to 2, and then
Yeah, that is why there is no assumption, because you do not know which one will start eventually first. If you just write a start, like thread 1 dot start, then thread 2 dot start, that doesn't mean this line will be executed always first and this will be second. It may happen this is executed first, this is executed second. Because ordering is not guaranteed, right?
yes, sir. So, okay, sir. So suppose this thread 1 starts, if we assume, then it will make request 1 as true, return equal to 2.
Yeah, if you guarantee that this thread will start first, then you can also guarantee what will be the turn value first. But the problem is, since it is executing in an interleaved manner, you do not know what ordering it will execute, right?
Yes, sir. Yes, sir. So suppose thread 1 starts, then what will be request 2's value?
That is what you do not know, right? That time. And you do not have to know also.
Okay, so it will not, it will
It is
be
the
null.
AND condition, right?
Yes.
It is a AND, right?
Yes, sir. Okay. So if thread 2 doesn't start, then request 2 will be null, right? So that is why it
It's
will
a
not be.
Boolean value. You can assume it could be a false, right? It's a Boolean. Either it will be true or false. It cannot be null.
Okay. So initially it should be false, right? Both request 1, request 2
Yeah,
should.
in case of Java, it should be false. Again, I'm saying there is no guarantee. So you have to write an algorithm, whatever the value may be, your program will work. That is what he's saying. There is no assumption you should do. So whatever the value should be, it could be true or false. Anyway, your code will execute.
Okay. Sir. Okay. So initially it will be false, but
So whenever
you
thread one
know
is
which one to use.
executing, it will do its proper job without referring to what are the values are there to request to and turn. That is the point is.
Yes, sir, but in the while condition, it will check request to value. So initially it should be false. Like if suppose thread 1 starts, it could be other way also. Thread 2 will check the request 1, but whichever does first, so other one should be false.
Again, I'm saying false in case of Java, but there is no assumption. Your code is written in a way, whatever value may be, your thread will be executing properly. That's the point is.
Okay, sir.
Then there is a bakery algorithm which is discussed. So this is again a theoretical algorithm discussion, how you can identify basically your threads are entering into a deadlock situation. So please read it because this theory and all, we do not ask much questions. Test and set is something like I have a lock kind of a thing. I test is it open, if it is locked or unlocked. If it is unlocked, then I lock it and do something, right? Then whenever my job is done, then again I unlock it. Then there is a semaphore also there. Semaphore also discussed over here. So semaphore is say one thread. So there are multiple. So sorry, if this is a binary semaphore, like which basically C. So there are two functions. One is P, one other is V, right? So what happened? The P function internally execute this code. So it basically check the semaphore value is positive or not. If the value is positive, it decrements the value, right? And otherwise, if the value is zero or a negative value, it will wait until and unless it becomes a positive, right? And this V function basically add up, increment the value, increment the value. So that is what happened. Yes.
Uh,
So yes.
Sir, what is this semaphore? If you can brief a bit, please.
Semaphore is basically is a technique for mutual exclusion actually. So which go by this algorithm of test and set. So you test it, either it is a locked or unlocked. If it is unlocked, you go for executing the critical section and lock it so that nobody else can enter into the things, because other people will come and find it already locked, right? Now whenever your execution is done, you unlocked it and go out. Now other threads try to check out the lock or the semaphore. It says it's already unlocked. So any of them will enter, again lock it. So that's the concept is. So there are two functions here, P and S functions. So how it will be executed, I'll just show you. So this is how it happened. So the P is for checking the semaphore, right? For checking the semaphore and lock it, right? And V is to release it, means releasing the lock. So whenever I have to execute the critical section, I'll execute the P function, right? If the P functions return that it is unlocked, then I'll go for execution, right? But if it is find it's already locked, then I'll wait still until and unless the particular semaphore becomes unlocked, right? And V, what happens once I have executed the critical section, I'll increment the value or unlock it. So the simple thing is is an integer value, right? So for the time being, assume it toggles between 0 and 1, right? The value of ace is the semaphore value. So there is different kind of semaphore also. I'm not going for that. It's a binary semaphore. The value is 0 and 1. Okay. So now point is, if the value of ace is 0, if I see the value of ace is 0, then I'll wait. I won't go into the critical section. So ace is 0 means it is locked. So I cannot execute. But ace value is 1 means what I'll do? I'll go for the execution. Right? So what P do? P function finds out the value of ace. If it finds the value of ace as positive, means if it is 1, then it decrement the value of ace, means makes it 0, means it will make it locked and go for execution. Right? But if the ace value is already 0 whenever I'm checking, then it will wait because it finds the semaphore is already locked by somebody else. Right? So what using P I'll do, I'll check the semaphore, whether the value is 0 or 1. If it is 1, I get access to the critical section, I decrement the value of semaphore so that other people will say the value is 0. And if people see the value of ace is 0, they'll start waiting. Right. Now what happens? I have already checked the value of ace. I seen it as a 1. I entered the critical section, reduced it to 0. So now other threads are trying to enter. So what they're saying? They're saying the value of ace is now became what? Negative. Right. So they will wait. Sorry, it became 0. So they will start waiting. Now I am executing. Once I have done, so I'll execute this V. V will do it what? Again, it will set the value of S to 1. So if the value of this thing is set to 1, what will happen? One of the thread will be raised, who will see the value of S is again became 1. So he will get access to the critical section, again decrement the value of S to 0 so that other threads now start waiting until and unless the thread execute the V. Do you get it?
Sir, so if there is no thread waiting, then only we'll increment S, right? Otherwise, we'll wake up one of
I
them.
didn't get you what you told.
No, sir, in
If
VFS,
no thread is waiting, then why I want to do anything at all? So
yes, we'll just else block, increment S. If their threads are waiting,
no,
then
no, not
wake it
like
up.
that. So this A's value, which is suppose initially set to 1. So at thread 1, suppose there are two threads want to execute. So first, suppose both check the P of S. So suppose eventually this has done first P of S. So he has seen the S value is 1. So he got access to the critical section. Right. So what it will do, he'll make set the value S equal to 0. Now what is happening? Thread 2 executing now P of S. He is saying the value of S of is equal to 0 now. So what will happen? He will wait. Now whenever critical section is executed, it will execute V of S. So V of S, what it will do? It will execute, increment the value of S to 1. So once S is become 1, so thread 2 was executing outside, right? So now it is set to 1. So it come out of the wait. So it enter into the critical section now. Set is again to 0. So again, if S is 0 means if again S1 is executing PS, now he will see now this S becomes 0. So he will start waiting now. Now once it is done, again it will set P V of S, means it will set S equal to 1. Now what will happen? This will get now execute access to the critical section. It will make S equal to 0. Now thread 2 wants to try this, again start waiting. Somebody see the value of s is 1, it capture the critical section, make the s value to 0, right? So that's why if I see the value of s is 1, I get access, but I set s to 0. So other people who are seeing s now, they will all see s equal to 0, so they will start waiting. Once I have done my job in the critical section, again I'll set s to 1. So other people now see it 1, so any of them will now enter into the critical section, again says s to 0. So it's toggling between 0 and 1. That's all.
Yes, sir. In VFS, what is it? If and else condition?
What?
No, sir. In VFS, there is if and else condition. So, what those if condition does?
In if condition, it is basically waiting. Still, it becomes a positive. So this is basically this part. So if I am on this part, other people on this part, right?
Okay, if they are waiting, wait. Else increment s.
Hmm.
Sir, is it possible that when two threads are checking for PS value, they both get value as one and they both enter at the same time?
We assume that these are atomic again. Then P and V operations are.
Okay, sir. So it means that only one thread can check the
Yeah.
value of
So that
PS.
is why this if part is given, because it only work up only one thread.
Okay, sir.
So this P and S, PFS and VFS, these things are implemented in Java using the locks, right? So lock is what semaphore in Java.
Yes.
Okay, because there is no PFS, VFS methods in Java.
Actually, this is very low level. Java do a little bit high level things. That's basically this monitor concept.
Yes, so that is synchronized, but the semaphore is also that locks. Can we?
It's there. So this is basically realized through a monitor in case of Java. So you can have your code along with data. So enter access can be control. So a part of enter code, right, which is having um, some code along with data, the enter thing access could be controlled through a monitor. So how this monitor is actually implemented in Java, that's using this synchronization method, right? Synchronization method and synchronization block. So I've seen 2-3 programs on those things. So there are a lot of discussion how this has happened and all, but there is somewhere it is there. No, in the next one it is there. So this wait and this monitor I'm telling next, right? I'll come back to this. Let me first say the synchronization. So this is week 11 content. Okay. So actually, no, the first decision in monitor, either I can enter into the monitor or not. So that will be decided by the synchronization keyword. So there could be a synchronization method or synchronization of code. So I cannot remember sir has shown the synchronization code here, code block. So anyhow, I have shown you. Yeah, it's there. So I've created an object called lock, right? It's the same thing he has done. He took a O instead of writing it as a lock. This is also we have done, right? Synchronized with this. The current object will be locked. So now if you look into a monitor, right? What synchronization decide who can enter into the monitor. So if you do a code as an synchronize, if you do a code which calls a synchronized, then what will happen? One thread will enter into the block, that monitor part, execute it, right? and come out, then only other thread can enter into the monitor and execute. So that is who can enter into the monitor, that is decided by this synchronization. So synchronization guarantees that only one thread will be executing the monitor inside the monitor. Is it okay? Is it okay?
Yes, sir.
But this wait and notified, I have explained in a different way. That I have explained a problem called as a consumer producer problem. Can you remember that? That we are having a buffer, one person is writing, another person is consuming it. So I cannot produce until and unless it is got consumed. And again, I cannot consume it until and unless it is got produced, right? So this produce of the object and consumption of the object should happen in a synchronized manner. So I should always produce first, then it should be consumed. Once it is consumed, then only I can again produce. So this is called a wait and notify kind of a problem. So this may happen inside the monitor. So synchronization decide, can I enter into the monitor or not? So my thread can enter into the monitor or not, that is decided by synchronization. Other threads are waiting. But it may happen, there is a condition which may, when I enter into it, I may put it into a wait queue. So suppose I'm a producer thread, right? Or yes, suppose I'm a consumer thread. But I see there is no data produced by the producer. What will happen? I'll be put into a wait state. So I'm inside the monitor, but still I'm waiting. So there is another queue. So already the the producer thread is waiting. Now in that case, even though I'm waiting inside, this will be let into, right? Now what it will do, it will produce, after producing, when it is going out, it will say notify. Notify will notify the thread is waiting. So what will happen now? This will start again execution. So there could be two wait queue. One wait queue is created by the synchronization keyword, which happens outside the monitor. That says one thread is entered into the monitor, other threads have to wait. But suppose I enter into the monitor, but due to some condition, I need to wait. Right? Suppose I want to do a withdrawal, but I don't have money. But I'm sure somebody is depositing into my account. So instead of going without doing the withdrawal, I'll wait for some time. So I start waiting. So if I move into the wait, since I'm inside the synchronization block, means inside the monitor, but I'm not executing right now. The other thread, which may be the deposit thread, will be allowed to enter into the monitor. Once it is deposited and coming out of the monitor, it will notify me so that I can resume my execution. So this is the enter thing. But again, I want to say the synchronization is quite a straightforward concept. You just write the synchronization keyword properly, it will happen, right? But wait and notify, you need to do it cleverly. You need to understand, rather I say you have to do it wisely. You need to understand which moment you should go for a wait, which moment you should say notify that I have updated it, so you can come out of the wait state and you can do the execution. So again, I'm repeating, if you go through all the programs I've done, I don't think you'll have any problem at all. Okay, so I've moved to the next one. So in this,
Uh,
yes, yeah.
Can you brief on this monitors as well, please? Like
Which one?
monitors.
No, you want me to repeat the same thing what I discussed here?
No, sir. What a monitor is actually. So
Monitor is basically kind of a black box inside which you are having some code, some data, right? So which you want to execute. Now monitor is something only one thread can enter into it at a time, right? So that means the access will be in a synchronous way, but it basically maintain two kinds of a queue. One will be an internal queue, another will be external queue. So why that happen? So somebody wants to, I'll come back to this slide. Actually, main thing is there in this slide only. Attach synchronization control to the data that is being protected. Monitor is like a class inside OOD, object-oriented programming. So it has the data definition, right? Whose execution has to be, access has to be done in a thread safe way. Means one thread at a time can execute it. And also you can identify the functions which do access to those shared data, which has to be executed again in a mutual exclusive manner. So basically the idea is all the code, all the data which you want to execute in a mutual exclusive manner, in a synchronized manner, you put it into a monitor. So monitor kind of a black box which guarantee only one thread at a time execute inside the monitor. I won't say enter. Multiple threads can enter, but only one can actually execute. Why? This internal and external queue are very important. So initially all the threads are waiting on the external queue. Right? Now only one thread will be allowed to enter into the monitor. So since it is enter, it will start executing the critical section. Now once it has started executing the critical section, it may happens due to some condition it cannot right now do the execution. So condition, I have given some examples. Suppose it's a producer consumer problem. So there is a buffer. Producer put some data, consumer consume it. Now suppose consumer enter first. It do not find any data produced. So it has to wait. The data will be produced, then only I'll consume. Right? Suppose there is a factory, so inside which a chocolate will be produced and somebody will consume it. So there is a buffer of one chocolate only. So until and unless that is produced, nobody can consume it. And until and unless somebody consume it, no place is left. So you cannot produce also new chocolate. So it has to be done in a synchronized manner. So that is why the internal queue is required. So some condition, if it is not fulfilled, now again, it is inside the monitor, but it is still may waiting inside the internal queue. So in that case, what will happen? Another thread will be enter into the monitor. It will be allowed to enter into the monitor. So if for that particular thread, if the condition is satisfied, it will execute the critical section. But before it will go out, it will notify the waiting state that I have set the condition. Now you can start execution. So as I've given the example of this producer and consumer problem. So this monitor, in the sense, I say this is the portion of the data where I access my buffer. So this is my buffer. So I want to check inside the buffer data is there or not. If data is there, I'll consume it. If it is not there, I have to wait. Producer, what will do? If no data is there, it will produce the data. Otherwise, it will wait because somebody will consume it. Then only it will produce new data. Right. So this is the idea. So initially both the threads are waiting outside. So this is external queue. So both the threads are waiting. Now suppose consumer enter first. Now it finds the buffer is empty. So what will happen? It will go for waiting. Right. Now in that case, this producer will be allowed to come. So it sees it is empty, so it will produce the data. Right. Now once it is produced the data, it will notify that I have already produced the data. So it will notify it and come out, so that once it is got notified, it will start execution, means it will consume the data and it will do the rest of the execution. So this is what happens inside the monitor. So the outside, the external queue will be controlled by this synchronized keyword, which could be a synchronized function or a synchronized block. But inside the internal queue, if I want to join the queue, I'll say wait. So I'll be put into the queue. Now, I cannot myself come out of the queue. Somebody has to notify me. I have reset the condition. Now you can enter. So that is notify. So wait and notify basically control the internal queue. Okay.
Okay, so this monitor in the programming code, how do I identify?
Uh, I didn't got you.
Sir, in this code, how do I figure this
So
monitor?
monitor is, it's a theoretical concept. That is what I told, right? So which is basically realized inside your Java code. This external queue is controlled by this keyword called as synchronized, right? And there are two keywords over here. This is wait, and there was somewhere this notify function, right? This notify function. This basically control the. So this is basically the entire concept is abstracted using this wait and notify functions and this synchronized keyword.
Okay,
So
so
this is the internal concept how this synchronization will be actually happening inside.
okay, so this monitor is not a class by
No,
itself.
no, monitor is not a class. It's an abstraction of a kind of a mix of code and data. So you can assume a piece of code inside your entire program, suppose 10 line codes, which you find it as a critical section, you can assume it as an monitor. So first you decide that only one thread enters into that portion, right? That is ensured by the synchronized keyword. But again, inside that, if you want to check certain conditions, suppose you want to withdraw from my account, right? You have a withdrawal function, and withdrawal function is a synchronized function. So that enter function works like a monitor. So any thread can enter into it, other threads will be waiting. Now you enter into the withdrawal function, but see that the balance is not there. So you'll be waiting. Now another deposit will be allowed to enter into the monitor. So he'll put some money, then notify the withdrawal that now you can proceed further.
Okay, sir, got it.
So the entire concept is realized by this synchronized and wait and notify keywords.
Thank you, sir.
Okay.
So,
Yes.
sir, you said that two queues will be maintained for one for the thread which is waiting from within the monitor and one from which is waiting outside the monitor, sir. Sir,
Yes.
let's say if a thread is waiting from inside and another is waiting from outside, and the third thread is executing within the monitor and it completes its job and it invokes notify all. So, sir, what will be the sequence? I mean, is
Notify
there
all
any...
will raise the threads which are inside the internal only.
Okay, so the first internal will be notified and then external threads will
If
be...
it is doing the notify, then always it will from the internal queue only.
Okay, so sir, there is another method, notify all. So it will notify everyone.
Yes, but any of one of them will be capturing the thread. So there will be again a race who will capture the control.
Okay, sir, in there will be
See,
no order
see,
for internal,
yeah, that is
external.
what. Suppose I'm thread 1, thread 2
Yes.
and 3 waiting. See, notify, I specifically say which thread to raise, right? Suppose I want to say I want to raise the thread 1 only, so thread 2 only. So then notify. But I don't want to specify which thread I want to raise. I'll say all. So 2 or 3, any of them will come into it. So I don't bother.
Okay, so irrespective of whether they are waiting internally or externally.
No, internally only. Notify works for the internal. Because if
Sir,
you
then...
come out, then the automatically no threads are there inside. Automatically, and one thread from the external will enter. But if already some thread already in the waiting, so nobody can. So first you need to complete the internal thing, right? Then only the external thing will be happening. So notify raise from the internal queue only, because notify raise only the threads who executed the wait. Right. So
Uh,
if you go out of the synchronized section, like which marked as a synchronized method or synchronized block, then only other threads can enter into your synchronized block, right? But
sir, let's say...
notify can only raise a thread which is called for a wait.
Sir, if I mean a thread is trying to get inside that monitor, but it has not yet got a chance, and it is still waiting outside the monitor, and
Hmm.
you are saying that notify will not affect it.
No, no, if it is outside, it won't affect.
Okay, sir.
So outside thread will only enter if nobody is executing inside. Means
Okay,
one
sir.
thread could be there in a wait state, state means it is inside but not executing. In that case, outside thread may enter, right? That is why before the thread go out, it's a notify so that internal thread will be raised and start.
Okay, sir. Got it, sir.
Okay, next, this is having some primitive Java functions. So I already discussed about the start explicitly execute the thread, but run function do not raise a thread. It's basically a serial call to a function, run function. So the main thread only will be calling that particular function. Interrupted exception, many of the thread function throws this interrupted exception like thread.sleep, then join function, right? Because if thread is already not executing, you cannot put it in a sleep or you cannot call a join, right? So that's why but this interrupted exception is a checked exception, so you need to explicitly handle it. Everyone please do this join function very well, because there will be definitely some question on the join. This is very important function. So this I already told, wait and notify start. Somewhere this join function is this discussed. Where it is. This yield is not so much required. I think it got depreciated now, but you can just read it theoretically. But very important is join, okay? So you can find there are a lot of questions in assignment and previous years which are based on join. I have also shown you various versions. Suppose main execute something, then two threads also execute something, and which point you are calling this join on the threads, that basically having a lot of effect on the output, because join say that I'll wait, let you complete your execution. So in the main thread, if I'm saying join on T, that means I wait T to complete its execution, then only I'll start execution myself, right? So using join, you can do very nice control of the threads. Although you cannot predict the order, but you can control like which thread will complete first, which thread will go next, right? So all the programs you have different places, different question papers, please practice everything, because join is very, very important mm, from the exam perspective. Okay. So please practice this. Again, if we have a session on Friday, doubt clearing session, if you are finding difficulty, we'll sit, or you may post it on the discourse also. We take care.
Okay, sir.
Okay, so next one we have discussed another way. So this is just a concept discussion, right? We don't have. Where is this re-entrant lock? Which, so this we don't have any this thing. This is just a concept. Please read it. No question will come from this actually. So, but this is required for understanding. Re-entrant lock. Did you remember where we have re-entrant lock? Yes, yes, this one. So this is important, okay? So re-entrant lock, is this very similar to your synchronization block only, right? If you understand synchronization block, you should not have difficulty to understand this re-entrant lock. I've also shown certain programs of re-entrant lock. But remember, re-entrant lock is much more, give you much more sophisticated control than your synchronization block. One more thing, if you're using this re-entrant lock, you have to lock it. Whenever you want to go out of the critical section, you need to unlock it. Otherwise, other threads will go for starvation, right? So if you lock the critical section, then do not unlock it. Nobody can now enter into your critical section. It becomes ever for starvation. Okay, so this re-entrant lock is very important because it gives much finer control than a synchronization, but its very usage is very similar to the synchronization block itself.
Sir, so this is what is similar to that semaphore. Like, dot lock is like that P of S and unlock is like V of S. in Java.
All are basically realization of the concept of semaphore and monitor only. So if you see monitor is basically again encapsulating the idea of semaphore, and these are everything we are doing. Basically, internal theoretical concepts are those. So we read the theory, then write some codes to implement it, right? So this is basically called as a code abstraction. So inside this, basically the entire lock is implemented. Yes, you can assume it as a, this is like a P and this is like a V. The last one, we have this thread safe collections. So what happens? Our usual collections are not thread safe. What does it mean? The term not thread safe? It allows basically different threads to do read write operation concurrently on a collection. Right. So I am having a list. So our thread is writing from 1 to 10 position. At the same time, another thread trying to read from 1 to 5 position. So that is called a thread unsafe operation. Whenever a number of threads are allowed to access the same collection concurrently, because it may result in a inconsistent data or results. So what happens whenever you do a unsafe code uh, with your usual collection types like array list or tree set, etc.? It basically fire an exception which say what it calls that exception concurrency. Somebody tell me. I cannot remember the name. What exception? It's not written also here. Okay, anyway, it will throw an exception, concurrency exception. If it
Modification, concurrent modification.
concurrent modification exception, right? So if it finds any time like two threads or two or more threads are entering into the collection and trying to do something, it fired this exception. So best way to deal with it, use the concurrent version of it. Right? You are having concurrent version of map, list, and dictionary, right? Hash, right? So this thread shape, the concurrent version, do what? It do not let only different threads to enter, more than one thread to enter into the into your collection. Means one thread is reading or writing, means other thread has to wait. One thread will complete its operation, then only other thread will be allowed to do it. So that's do the access of the thread in a synchronized manner. Access to the collection in a synchronized manner. But the question is why I don't always use the concurrent map or something. The point is if you take a concurrent map or a thread set collection, your parallelism will go off, right? You cannot do something simultaneously. You have to always go serially. So you need to understand the situation and use for what we should go for. If the synchronization is an issue for your program, then you'll go for the concurrent version. If there is a no concurrency issue, we'll go for a normal version. Because the normal version you let you use the concurrency, but concurrent version do not let you use the concurrency, because that may result in an inconsistency. So that is a decision you need to take, which one will go. So that's all. Questions?
So what kind of questions will be as part of this reintent log and
You
thread?
can see all these old question papers or this assignment, the similar only. There will be code given, right? And we normally ask that what are the possible outputs, right? Which kind of output never can come for
Okay.
a certain program, right?
Sir,
Be
could you please
careful.
conduct one session for PYQ?
Okay, I'll see to that. Normally, I do not prefer to do PIQ. I want people to come up with the questions so that I'll solve it, but I don't like to do it, but anyhow, I'll see if it is possible in any way.
Maybe 1 or 2 questions.
Actually, I don't want to do it only, so I'll check out, because I think that basically reduce your capability to study the PIQ sessions. So you should try to solve. If you fail, then only raise with the questions. Otherwise, it's not a good way to do. Anyhow, I'll see what is possible. Okay, then. If there is no question, we'll close it. Yes.
Sir, I have one doubt. Can I share
Yeah.
my screen then?
Okay. Anything else? Anybody having any questions? Other question? I'll stop the streaming then.
No, sir.
Okay. I'll stop the streaming.